So before we run through this example of how we can figure out the specific heat of zinc metal, I want you to get a piece of paper out because I want you to record all of the data that we're going to collect in this video lab that I'm about to show you. So I want you to write down zinc metal, this is the mass of the zinc, the specific heat of the zinc, and the change in temperature of the zinc. And then we're going to have another table that has to do with the water. We have the mass of the water, the specific heat of the water, and the change in temperature of the water. And then, of course, we're going to use Q equals mc delta T on both sides. And remember, our goal, let me go back, our goal is to calculate the specific heat of this zinc. So we're going to show you how to do this with an example problem. And as you go through, I want you to record your data just as I do. Okay, so we're going to start this video here, and I've got my table over here, and I'm going to label something that my system is the zinc, because that's what I want to learn something about. I want to learn the specific heat of zinc. So it's the system. The water are the surroundings. Now let's think if we know anything, because generally speaking, we need all of this information about both of these metals, or both of these substances, before we can do any math with them. It turns out before we even do the experiment, before we even turn on the video, I do know some things. Like even though I don't know the specific heat of zinc, I know the specific heat of water. It's 4.184 joules per gram degrees Celsius. Because we saw that in a table earlier, right? Now we're going to turn the video on and we're going to see if we can spot anything else. So the piece of zinc that I have came from the same kit, so it looks pretty much the same. It's just a little darker gray. And this is going to be the mass of the zinc. Whoop, let's go back. That was too fast. Right there. I didn't want to lose that mass of zinc because I wanted to make sure I get that right. So we'll say it was 70.76. We definitely need a unit. What unit our balance is always using? Looks like there's grams right there, right? So grams. All right, we've recorded one thing. Let's see what else happens here in this calorimeter. Now we know we've got to get this metal hot, right? Because we're going to throw it into the water and have it raise the temperature. So we're going to take our zinc metal, put it in the oven. This seems perfectly safe. And we're going to heat up this oven. Now I'm putting in a thermometer because, you know, my oven has one, but it doesn't measure in degrees Celsius, and we need Celsius. So it's the left side that's heating up here. The right side, that's just a set temp. So we're going to see how high that temperature goes, because since the metal's in the oven, we're going to assume the metal's initial temperature is there. So I'm going to say 228. All right, let's do 228. So I'm going to say initial is 228 degrees Celsius for the zinc. Now, as we said, we're not going to be using that styrofoam cup. We're going to be using a beaker. However, I should say that we're not going to measure the volume in the beaker or the mass in the beaker. What we're going to do is we're going to use a graduated cylinder to get a really exacting amount. If you look at the volume of water here really carefully, so I've stopped the video so that we can see it, we need to measure this pretty accurately. Now I see 40 down here, I see 50 up there, so I'm thinking 41, 42, 43, 44, 45, 46. The bottom of the meniscus looks like it's not at 47, it's somewhere in between. So I'm going to say 46.5. Does that sound good? 46.5. Now this 46.5 milliliters of water, we're going to say is 46.5 grams, because you remember the density of water is about the same. But that's not the mass of the metal, that's the mass of the water we're using. We've got to keep track of that as well. So 46.5 grams. All right, seems reasonable. Now we've recorded a lot of our data, but you notice we still haven't done the change in temperature. The only thing we know is that the initial temperature of the metal is really hot. It's 228 degrees because it's sitting in that oven. So what we want to look for is, what is the initial temperature of the water? Now I think that's going to be roughly room temperature. Let's see. All right, so we're going to take our accurately measured water and pour it in the beaker. Remember, we can't measure volumes accurately in a beaker. That's why we did that. It says 19.6. So our initial temperature of our water is 19.6 degrees Celsius. Now, we don't know the final temperature of the metal, and we don't know the final temperature of the water. But one thing that's going to happen as we put the metal in the water is the water is going to warm up in temperature, and the metal is going to be cooling down. I think you'll see it when I put it in here. I mean, the metal's so hot, like the water fizzes for a second. But the metal's going to be coming down in temperature, and the water's going to be going up in temperature. And wherever the water stops, at that moment, we're going to assume the metal and the water are the same temperature. Let's see if we can see that happen. Now, I think that's hot. Oh, yeah, look at that. You can see the water fizz. And we'll see the temperature starts to go up in the water. The metal's cooling down. The water's getting hotter. I want to stir, but there's not a lot of room. But look at the temperature, 36, 37. Now it's slowing down, but still warming up. We're looking for the highest temperature it reaches, 38.0, 38.1, 38.2, 38.3. Is that it? It's been there a while. Now, if it starts to go back down, I'm going to say this is the highest, 38.3. Let's wait and see. Yeah, it's starting to go down. All right, so the highest temperature it reached was 38.3 degrees Celsius. So now we can find our change in temperature of the water. But how do we know what the change in temperature of zinc was? Well, zinc started at 228 degrees. It was really hot when we threw it in there. What should we use for its final temperature? Well, if you're thinking it's sitting in here with the water, it probably is now the same temperature. You are correct. We should use the same 38.3 because their temperatures became the same because they were sitting there together. That's why the water stopped warming up. So that's one of the tricks to calorimetry is before we do the math, I want to point out to you that the strategy for dealing with it is always divide your page in half. Put the metal on one side, put water on the other. And then write down all the variables you will need to do Q equals mc delta T for both sides. Leaving that specific heat of zinc. Because, watch how we solve it next. I always solve the math on the water side first. So water side first. Let's do Q equals mc delta T. Well, we have all the information here to actually calculate Q. Q equals, M is 46.5 grams. C is 4.184 joules per gram Celsius. I'm going to leave that off because I don't have a lot of room. And then my delta T is subtracting these two, final minus initial. And so I get, let's see if I can fit it in here, I get 18.7 degrees Celsius. It should be positive. Let's see if I can fit a parentheses. Should be positive because it went up in temperature. Now, if I multiply those three together, I get Q, the amount of heat absorbed by the water is positive 3,638 joules of energy. That's how much heat the water absorbed. So the heat went out of the block and into the water. And that's how much heat the water absorbed. Now, of course, that heat came from the block. So the heat for the block is negative 3,638 joules because the heat was leaving the block, and it's the same amount of heat that was used in the water. Okay, if we want to solve for our specific heat, we now know the mass, the change in temperature, and the heat for zinc, and we can solve for C. So I'm going to do that over here. If Q equals mc delta T, then I can plug in my values. So I've plugged them in. Here's my Q. There's my mass. And remember, I need the mass of zinc. I'm solving for the specific heat of zinc. That's why I left a little label on there. And then I have to do final minus initial. Well, my final temperature was 38. My initial temperature was 228. And when I subtract those two, you notice I'm going to get a negative number. And then once I get that, you see that negative number right there because it went down in temperature. Then in order for me to get C by itself, I'm going to have to divide by 70.76. So I get negative 3,638 divided by 70.76. And I'm also going to have to divide by negative 189.7. So that's going to end up down here as well. And all of that will equal my specific heat. And when I go negative 3,636 divided by 70.76, hit enter, and then divide by negative 189, the specific heat of zinc turns out to be negative, not negative, what am I thinking here? Positive 0.271 joules per gram degree Celsius. So I wonder how we did here. I wonder how close we were. Now I do have some worries, of course, like you guys know we were supposed to use a styrofoam cup. That was one of my worries. I thought some heat might leak out. So we might be a little bit off. The other thing that worried me is, you see the little hook isn't under the water? That's kind of an issue. We want the whole thing submerged. And then lastly, it took me a moment to get it out of the oven and into this beaker. So I'm thinking maybe some of the heat escaped before we got it in there. So let's see how we did. If I look for the specific heat of zinc, remember we said 0.271. Let me write that down. We said zinc specific heat is 0.271, and there's zinc. Oh, we were a little bit low. It's not awful, but I think a lot of those things, allowing some heat to escape before we got it into the beaker, that was one problem, and not using a styrofoam cup. Those things are going to cause us to be a little bit low, but not bad. If we were more careful with better equipment and it came out exactly to be 0.389, we would know that it was zinc. Now you might say to yourself, maybe it isn't zinc. Maybe I had it wrong. Maybe it's actually silver. Silver's a little bit closer. Now I think the authors told me it was zinc. We were just off in our measurements. But you can see the idea that if you can measure the specific heat, you can actually determine which metal it is if you're very careful in your measurements. But the key to this all, and the notes that I want you to get down here are, well, first, list all the stuff in Q equals MC delta T on both sides. The system side where you have the metal and on the water side. And put little labels on them to tell yourself what you're talking about. Then fill in what you know about each one. And finally, come back and in order to figure out the specific heat of zinc, you've actually got to start your math on the water side, calculating heat. Once you know the heat here will be exactly the same value. The only difference, same value, is the signs will be different. This one will be negative. And then the other tricky business, of course, is the final temperature of the metal in the water is always the same. That's the last trick to it.